AP Biology students, this is going to be our second video about the statistics assignment where we go over more standard deviation problems. This is going to be on questions 3 through 10. For each of these questions, I would use the bell curve or the standard deviation graph because that's going to make it a lot easier to visualize and to understand what the question is asking for. And as you can see for each of the questions here, I added that bell curve or the standard deviation. Remember, on these graphs, the average here is going to be in the middle while we add and subtract a standard deviation going from right to left. So as you can see, this is +1 standard deviation, +2, +3. Then we go -1 standard deviation, -2 standard deviations, and -3 standard deviations. These percents show how much of the data should fall between each of the standard deviations. And lastly, just remember that 68 falls between the first standard deviation, 95 falls between 2 standard deviations, and about 99 falls between 3 standard deviations. All right, let's get into it. Battery lifetime is normally distributed for large samples. The mean lifetime is 500 days and the standard deviation is 61 days. Approximately what percent of batteries have lifetimes longer than 561 days? Again, remember 500 days is the average, which is right here. +1 standard deviation is going to be 561 days. So what this question is asking is what percent of the batteries are going to last more than 561 days? To find that answer, all we have to do is we have to calculate what this portion of the graph is. Remember that the whole graph is going to be 100%, so all we have to do is we have to take that 100% and subtract these numbers, and what we get is 16%. 16% of the batteries are going to last longer than 561 days. Next question, Professor Halen has 184 students in his college mathematics lecture class. The scores in the midterm exam are normally distributed with a mean of 72 and a standard deviation of 8. How many students in the class can be expected to receive a score between 64 and 80? Remember that the average is placed here in the middle, which is going to be 72. What this question is asking is how many students are going to fall between 64 and 80, which is 1 standard deviation around the average. If we add up both of these numbers, it's going to be 68%. So what we have to do is we have to take 68% and times it or multiply it by 184 students, and we're going to get there are 125 students that should fall between this first standard deviation. Question 5. A test was given to 120 students and the scores approximated a normal distribution. If the mean score was 72 with a standard deviation of 7, approximately what percent of the scores were 65 or higher? So again, our mean here in the middle is 72. To find our first standard deviation in the negative direction, we're going to take 72 minus 7, which is 65. So again, this question is asking how many students are going to have a 65 or higher. If you add up all of the percents of these standard deviation sections, it's going to be 84%. Now what we can do with that number is multiply it by the number of students and get there around 100 students that are going to fall between this -1 standard deviation and our top score. Question 6. On a standardized test, Kathy has a score of 74, which is exactly 1 standard deviation below the mean. If the standard deviation for the test is 6, what is the mean score of this test? So again, Kathy had a score of 74, which is exactly 1 standard deviation less than the mean. If the standard deviation is 6, it's asking what is the mean here? So again, Kathy scored a 74 right here. To find the mean, we have to add 6 since the standard deviation is 6. 74 plus 6 is 80. So the average for this test is 80. Question 7. On a standardized exam, Laura received a score of 85, which is exactly 2 standard deviations above the mean. If the standard deviation for the exam is 4, what's the mean of this exam? So again, Laura received a score of 85, which is 2 standard deviations above the mean. If the standard deviation is 4, we have to subtract 4 twice to find the mean. So again, Laura's score was 85. The standard deviation is 4. We have to subtract 2 of those, so it's 85 minus 8, which is 77. The average of the exam was 77 for the class. Question 8. A shoe manufacturer collected data regarding men's shoe sizes and found the distribution of sizes exactly fits the normal curve. If the mean of the shoe size is 11 and the standard deviation is 1.5, find the probability that a man's shoe is greater or equal to 11 or greater than or equal to 14. Wow, there's a lot in this problem. So again, men's shoe size has an average shoe size of 11. That's going to go here in the middle. Each standard deviation is 1.5, so we add and subtract 1 standard deviation or 1.5 to that 11. So the first part of this question is actually kind of easy. It says, what's the probability a man's shoe size is greater than or equal to 11? That's kind of actually pretty easy since 11 is here in the middle. That means 50% of males are going to have a shoe size larger than 11. So again, 50% right here. The second part of this question is going to ask how many men or what percentage of men are going to have a shoe size larger than 14. That's 2 standard deviations above the average. If you go back and remember that 2 standard deviations here are going to encapsulate 95% of the data, that means 5% is going to be located here on the ends. Since we're not talking about both of these ends, we're going to incorporate this data that's not being included in the sizes 14 or above. So what we do is we take 5 and divide it by 2 and get this 2.5%. So there are 2.5% of males that have a shoe size larger than 14. Question 9. A bag of chips has a mean mass of 70 grams with a standard deviation of 3 grams. Assuming normal distribution, create a normal bell curve including all the necessary values. I don't have a graph made for this, but we're going to put 70 grams in the middle here because that's the average, and 3 standard deviations above and below for each standard deviation. The question asks, if 1,250 bags are produced each day, how many bags will have a mass between 67 and 73 grams? Again, this is kind of an easy question because it's just looking at this percent or this margin of the data. Because 70 is here in the middle, positive and negative 1 standard deviation would be between 67 and 73. So again, we take 68% and multiply it by 1,250 and we get 850 bags. So 850 of those bags are going to have a size between 67 and 73 grams. All right, last question. The lifespan of a 60-watt light bulb produced by a company is normally distributed with a mean of 1,450 hours and a standard deviation of 20 hours. If you can't tell, I'm running out of steam on this one. If a 60-watt light bulb produced by this company is selected at random, what is the probability that its lifespan will be between 1,410 and 1,490 hours? There are a lot of numbers, so make sure we have the right numbers here. So again, the average is going to be 1,450. If we take a look at the standard deviation, we can see that what the question's asking is how many of the light bulbs are going to fall between 2 standard deviations. Yes, this question's only asking what percent of the light bulbs are between those 2 standard deviations. It's just 95%. This is a difficult question just because there are so many numbers. What the question's actually asking for is pretty simple. It's just what are the percents between 2 standard deviations. That's 95%.